Hey everyone, today's video is going to talk about the properties of integrals, and so really you're not going to be learning too much new here, but what we're going to be doing is formalizing the ideas that you saw in today's investigation. So all of these ideas you saw in the investigation, we just want to make sure we know what all these properties are. So the first property we're going to talk about is the order of integration. Right? And when we're talking about that order, what we're looking at is the order of the bounds. So example over here, I see that I'm integrating from A to B. So if I look at my diagram, you can see if I'm going from A to B, I'm moving to the right. And in this case, because we're above the x-axis, we have a positive area. Now, if I were to take that and switch the order of those bounds, so in this case I'm going from B to A, now I'm going backwards. I'm starting at B and moving my way left. And what that does to the integral, if the integral from A to B of f of x was s, then if I change that order, I get the opposite value there. So if the integral from A to B of f of x is s, then the integral from b to a of f of x is negative s. So it changes the sign there if I change the order. So that was our first property. The second property is what we call the zero property. So remember, when we're talking about integrals, we're talking about the area trapped between a curve and the x-axis between these two x values. Now, if I were to try to integrate from a to a, right? All I've got then is this kind of line there. I have not accumulated any area. So whenever my lower and upper bounds are the same, the value of that integral is going to be 0. Because again, in other words, I haven't accumulated any area. I'm going to make a note here. No area accumulated. All right, the next one we call the constant multiple here. So again, I have my original integral, the area, or the integral from a to b of f of x dx, and I know that's equal to s. So what we're looking at here is if I take k times f of x. Now, what I need to note here is these f of x here, these are the y values. Right? So it's like taking every y value between a and b and multiplying it by k. So I'm essentially kind of adding this area here because all those y values get multiplied by k. Now, when that happens, the effect is just to multiply that whole area by k. So if the original area was s, then taking the integral from a to b of k times f of x is the same thing as taking k times the integral from a to b of f of x dx, which in this case is just k times s. So we're allowed essentially to pull that constant through the integral symbol and move it out front. Okay, the next one we have sum and difference rules here. So this is when I have the sum or difference of two different functions. So you can kind of see here, now really let's consider, I think this says y equals f of x, but let's call this g of x. Right? If we're adding the value of those integrals, all we're doing is adding the area under this curve plus the area under this curve. And vice versa, if we're subtracting, we're just subtracting those areas. So if I have the integral of the sum or difference of two functions, that's the same thing as the sum or difference of the integrals of those functions. So that's the same thing as the integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. So we can basically just split those apart and add or subtract those areas. All right, so the last rule then that we looked at in the investigation looks something like this. We call it the addition rule. So you'll notice here I have two integrals, the integral from a to b of f of x dx plus the integral from b to c of f of x dx. And notice here my upper limit of integration is the same as my lower limit of integration here. So if I look at my first integral from a to b, I know that's telling me to find this area. So that was my first integral here. Now this is telling me to add the area from b to c. So I'd be looking for this area in green. So what we get then really is just the integral from a to c of f of x dx. When I add those two integrals, I'm just finding the integral over that whole interval from a to c. So those are the main properties, and we're going to use these when we know the value of one integral. We're going to use that to find the values of some other related integrals. All right, so let's take a look at some examples. Okay. So it says use the rules or the properties for definite integrals and the following known integral values to answer the questions. So they're always going to give us some known values, and then we're going to figure out the values of some related integrals. So let's see. We have two functions. It looks like f of x and h of x. So the first one, I'm finding the integral from 4 to 1 of f of x dx. So I have to see if I have something that's related here. And what I notice is that these two integrals are almost the same, but the order's changed. So that's where we would use that property dealing with the order of integration. I know that this is the same as the opposite of the integral from 1 to 4 of f of x dx. Notice that when I changed that order, I had to make this opposite out front. So now I have the opposite. Well, the integral from 1 to 4 of f of x is negative 2. So the opposite of negative 2 gives me a value of 2. My next one now, I have the integral from negative 1 to 4 of f of x dx. If I look up here, I notice I know the value from negative 1 to 1, and I know the value from 1 to 4. Again, since that upper limit is the same as the lower here, I know if I add those together, I'm going to get the integral over the whole, or the value of the integral over that whole interval. So this is the same as the integral from negative 1 to 1 of f of x dx plus the integral from 1 to 4 of f of x dx. Now I know both of those values. I have 5 plus a negative 2, and so I get 3. All right, now the last one, I see a couple of things going on here. The limits, it looks like I don't have to do anything there because I know negative 1 to 1 for f of x, and I know it for h of x. But I can see I've got the sum property here, and I've got a constant multiple. Now, as you go on, you won't write all these steps. I just want to show them to illustrate all the properties really clearly. So the first thing I'm going to deal with is this sum here. So we said the integral of the sum is the same as the sum of the integrals. So this is the same as the integral from negative 1 to 1 of 2 times f of x dx. Remember, I always have to close out that integral with the dx plus the integral from negative 1 to 1 of 3 times h of x dx. Sorry, I think I'm making this kind of dark here. Let's make sure you can see that. So all I did first was break up that sum. Now I can use my constant multiple property to pull these constants out front. So 2 times the integral of negative 1 to 1 of f of x dx plus 3 times the integral from negative 1 to 1 of h of x dx. And now I can plug in the values that I know. So I have 2 times, well, this integral is the value of 5 plus 3 times negative 1 to 1 of h of x dx is 7. So I have 10 plus 21 gives me a value of 31. Now again, I showed all of these steps just to show how those properties work. Once you get going with these, you probably will not need to show all of that to get your final answer. And I wouldn't require you to show all of these steps. I would, however, want to see what numbers you're plugging in to get your final answer. Okay, we're going to do a couple more examples here. It may be worth trying these, so pausing the video and trying them and then kind of checking back in. But same kind of process. So we have 4 values that we know, and then we're trying to figure these out. So again, this is similar to the one we just did. I have a constant multiple and a sum. So I'm going to kind of do 2 things at once. I know I'm going to break apart the sum, but I'm also going to pull out that constant. Now making note that that only applies to the f of x. So this is going to be the same as 2 times the integral from 0 to 1 of f of x dx plus the integral from 0 to 1 of gx dx. Now let's see, I have 2 times the integral from 0 to 1 of f of x dx is 1, plus the integral from 0 to 1 of g of x dx is 3, so I get an answer of 5. All right, my next one is the integral from 0 to 2 of g of x dx. Now, if I'm looking at g of x here, I only know the integral from 1 to 2 and 0 to 1. But since these have, again, same upper and same lower, I know I can add those together. This is going to be the same as the integral from 0 to 1 plus the integral from 1 to 2. And I have both of those values. 3 plus a negative 1 gives me a positive 2. All right, so let's see. Number 3, last one here. I have a constant multiple. So I'm going to deal with that first. I can pull that out front. And now I have a question about these limits of integration. Because I see I'm looking from 1 to 2. I have 0 to 1 and I have 0 to 2. So here's where I want us to think, and I'm going to draw a little picture to kind of help us with this one. I'm just going to kind of off to the side here sketch a graph, and this is obviously just made up. Let's say this is f of x, and let's say it looks something like this. And so this is 0, let's call this 1, and let's call this 2. Now, I know the value from this first integral, the value from 0 to 2, right? I know that if I calculated that, it would give me all the area from 0 to 2. But in my problem, I only want the area from 1 to 2. So what I need to do is to subtract off the area from 0 to 1. If I can take the whole area from 0 to 2 and subtract the area from 0 to 1, that'll leave me with just the area from 1 to 2. So what I'm going to do here, I need to leave that negative 5 out front, and I'm going to put brackets here. That's going to be the integral from 0 to 2 of f of x dx minus the integral from 0 to 1 of f of x dx. So now I have the values for that. I have negative 5 times the integral from 0 to 2 is 4, minus the integral from 0 to 1 is 1. So negative 5 times 3 is going to give me a negative 15. So sometimes we have to get a little creative with how we make these properties work for us. So those are all the properties that we have. Over the years, though, Mrs. Vasta and I have noticed that there are several common mistakes related to properties of integrals. So in addition to showing you what you can do, we wanted to make sure to emphasize what you cannot do. So the following things are properties that people assume they can make happen but are actually not true. So again, these are things you cannot do. So we're hoping we can help you avoid some mistakes that are commonly made. The first one, there is no multiplication property. So we know for addition or subtraction that the integral of a sum is the sum of the integrals. However, the product here, this is not equal to the product of these integrals. There is no multiplication property, so we cannot do that. The next thing that happens is that people see something like, let's say I told you that the integral from a to b of f of x dx equals, let's say it's 10. What happens is people see a problem like this where the bounds are both multiplied by 2, and they assume that they can just multiply this integral by 2. That is not the case. This is not equal to 2 times the integral from a to b of f of x dx. So in other words, in this example, if I had the integral from 2a to 2b of f of x dx, I could not say that that's equal to 20. That's not something we can do. We don't have a property because this changes the graph. And so that area changes. We're not just multiplying it by 2. Okay, the next one here, if I have the integral from a to b of f of x plus k, a lot of times people want to do this. The integral of a to b of f of x dx, and they just add the k. However, we saw in our investigation that adding the k shifts that whole graph up, and we create a rectangle under our original area. So we're not just adding the k, we're actually adding a whole other area. So we have to be careful here. Then the last one is when we're multiplying x by a constant. Right? When this constant is inside the parentheses, it's not just the same as multiplying everything by 2. Remember, that only works if that constant is outside of that function. So again, I want to be really clear. These are things we cannot do. These rules do not exist, and these come up a lot of times in multiple choice. They'll kind of try to trick you with some of these examples. So we'll be working with these properties tomorrow in class, so you'll get some more chance at kind of working through these. That is all for today. I'll see you tomorrow in class.